My dear students, today I am going to start your chapter of 10th class physics, reflection and refraction. Now, mechanics and optics is the oldest branch of physics. Here, reflection and refraction comes to the branch of physics known as optics. Light is always a matter of fascination from the early human beings also. Different scientists from the beginning, they want to measure the velocity of light because velocity of light is maximum in comparison to other particles. But here we should have to first of all a question arises here: what is light? What is light? What is light and what is its nature? What is its nature? First thing, light is a source of energy. Next thing is that as velocity of light is measured by the Michelson and Foucault, velocity of light in vacuum or air, velocity of light in air or vacuum is 3 into 10 to the power 8 meter per second. That is 3 lakh kilometer per second. That is 1,86,000 mile per second. And what is the nature? What is the nature of light? And at the beginning of the 20th century, earlier in the 19th century, 18th century, it was believed, some of the scientists telling that light has particle natures. Light propagates in a straight line. In the 8th class, in lower classes, we did so many experiments, and that proves that light propagates in a straight line. What is light? Some scientists are some of the phenomena like the photolactic effects. These things, if you consider the light is a particle, then we can prove this. If we are going to prove the interference, diffraction, polarization, then we should have to consider light is a wave. In 20th century, the quantum physics, quantum theory of radiations came in the existence, and it was told that light has dual nature. Sometimes it behaves like particles, sometimes it behaves like waves. But here, the reflection and refraction, when you go to the 12th class, then that time we will do the study of ray optics and wave optics. But in the class 10th, we should have to study only the particle nature of the light. That's here it proves that light has dual nature. Sometimes light behaves like particle, sometimes behaves like waves. Huygens, a scientist, gave the theory, wave theory. And Einstein's photoelectric equations told that light has particle nature. But here, these are the introduction of the light. But now, what is your syllabus? Syllabus is that reflection, first of all, first part of the chapter is reflection, and reflection through the spherical mirrors. First of all, we should have to know that what is reflection. When light incident on any of the surface, either it is regular or irregular, it bounces back in different directions. That is known as reflection. And definitely, we are familiar with the law of reflection. And just I am going to draw a figure here. It is an interface. This side is polished. If light, a ray of light incident on a point P, it is bounced back in this direction, making some angle with the normal. It's the A, it's the P, it's the B, it's the N. Pn is the normal. This angle APN, angle APN is the angle I, that is angle of incidence. And this is angle R, this is known as NPB. Yeah, we can say that BPN also. This is angle R, this is your angle of reflection. Pn is the normal, Pn is perpendicular to Mn, is normal to interface, that is on point P. Then now we are coming to the law. First law is that, again, the students, you are familiar with this law? Angle of incidence I is equal to angle of reflection R. This is the first law. Second law is that this our incident ray. We can say that AP is incident ray. Just we can write here AP incident ray and PB reflected ray. Next law is that incident ray AP, reflected ray PB, and normal PN to the point of incidence all lie in the same plane. All lie in the same plane. Here Mn is the interface plane. Here is the one figure. It's your x-axis, it's your y-axis, it's your z-axis. It is a three-dimensional figure, and this is x and this is y-axis. If we have a plane like this having two dimensions, that is known as plane. It means that if it will have the length and breadth, then it should be known as plane. All lie in the same plane. This is the law of reflection. Again, I am repeating the things. Angle of incidence I is equal to angle of reflection R. Next law is that incident ray AP, reflected ray PB, and normal to the point of incidence Pn all lie in the same plane. Now, we are going to just as my students, you are knowing that light is a radiation. Light is an electromagnetic waves. It needs no medium to travel. Reflection, here I have drawn a figure like that. Light, there is two types of reflection. One is regular reflection and another is irregular reflection. Regular reflection is those types of reflection which obey the law of reflection, and irregular reflection is that which doesn't obey the law of reflection. And one thing is that in this class we should have to study only the regular reflections. Either it is the, if we have a surface like that, even light incident on that surface, again it obey the law of reflection. And it is also necessary to know that we can see the objects when light is there. In dark room, even having an eye, we can't see the objects. So light is necessary to see any objects. So in the, if you have drawn a if you draw a electromagnetic, if you draw a graph of electromagnetic radiations, then if you have so many radiations here, but a small band of radiations that starts from the wavelength 4000 angstrom to 7000 angstrom, it is known as visible band of radiations. Visible band of radiations it is the wavelength, it is also the wavelength, and we have a formula like that, V Gore. Here is the shortest wavelength, here is the longest wavelength, and I think that it is just, you should have know only that. Here we can start from the gamma rays, having the wavelength 1 angstrom only, gamma rays, X rays. It is the shortest wave. It is the shortest wave, and longest wave is that radio waves. Wavelength is about 1 kilometer. My students, it is not in your book, but we should know, we should have to know that if you draw a line showing the electromagnetic radiations of different wavelengths, then the figure will be like that, and that is useful for, that is useful in the 12th class also, because I have told you that 10th class, syllabus of the 10th class correspond to the syllabus of the 12th class, and syllabus of the 9th class correspond to the syllabus of 11th class. Now we have finished the law of reflection. But from where? First of all, we have the reflecting surface. We are much familiar with the plane mirror. It's your plane mirror. Each and every household there is a plane mirror. If we stand in front of a plane mirror, we see our images, and one thing is that in plane mirror, size of the image is same size of the objects, and that is your image is at equal distance means behind the mirror you can notice that your image is the same distance as where you are standing in front of the mirror. And next thing is that your image is laterally inverted. In the plane mirror, if anybody can ask you, what is the nature of the image made by the plane mirror, then we have to say that, my students, the plane mirror always makes the virtual image, it is equidistant, the image is formed at the equidistance of the object, and next is that it is the same size of the objects, and also the image is laterally inverted. But our focus should be on the reflection through a spherical surface. Now, you write everything on your copy. Reflection through a spherical surface. First of all, we should have to know about the reflection through a spherical surface. Reflection here, the two type of surface. First is of concave mirror, another is of convex mirror. My dear students, you are much familiar with the spoon. Take a spoon at your home and you keep your spoon. You know that two sides of the spoon. First of all, you keep the deep side of your spoon in front of your face. Move the spoon backward or forward. You observe the nature of the image. Next, you invert the spoon and back side of the spoon. Again, you move forward and backward and observe the image. One, in the first case, it is like a concave mirror, and second case, it is like a convex mirror. It means that if the outer surface of a curved surface is polished, then this type of mirror is known as concave. If inner surface is polished and outer surface is the reflecting surface, then it is known as convex. And this spherical part is always, it is part of a sphere, like that. We can draw it. Definitely it will have in the center. And there are different things in the concave mirror. If you have to draw the ray diagram for image formation, you should have to be familiar with these things. One is that center of a sphere. Whose part is this spherical mirror? Center of the sphere is known as center of curvature. Again, radius of the sphere is known as radius of curvature of concave mirror and also the convex mirror. And half of the distance a half of the radius of curvature is focal length, and in different type of definition I will give you later about the focal length, about the focus. And here I am going to write the things that C is definitely the center of a sphere, and it is known as center of curvature. Center of curvature of respective mirror C. And here is a point, just you can draw. It is known as P, and we can draw it as a Mn. Mn is aperture of the mirror. And also the P is the pole of the mirror, and it is halfway of Mn. Here Cp is radius of curvature, that is your R. If we have taken a point F, it is known as focus, and Fp is focal length of the mirror, and it is a half of the radius of curvature. These are the things we should have to know about the mirrors. Now, what is the function of this mirror? क्या काम करता है? Function is that because till this time I have not told you about the image formation. And one thing I have left here, Cp, see, it is if you draw a line joining the center of curvature, going through the focus and reaching to the point P, it is known as principal axis. Definitely, we can trace back here. So C dash and P is the principal axis of the mirror. Now is near case is same also here, but here it is our reflecting surface in the case of concave mirror, and it is our reflecting surface, the bulging side of the mirror. In the case of convex mirror is our reflecting surface. Case the same also here. This is here the Mn is the aperture of the mirror. Now, we should have to, first thing, how image can we form? Image are of two types. One is real image, another is virtual image. If the rays are intersecting, really intersecting each other, and on that particular place a real image is formed, and real image we can draw it on a screen. First of all, how the image will be formed in the case of concave mirror, in the case of convex mirror. You should have to take so many convenient rays, as if you keep any of the objects in front of a mirror on principal axis, not a single rays but so many millions of rays coming out from this point A and B, rays, so many rays. But for clarity of the figure, you should have to draw some convenient rays, and for your betterment, for your convenience, I am going to draw 3 or 4 more convenient rays. If a ray coming out from any point and incidenting on any point of the mirror that is parallel to the principal axis, after the reflection, it goes through the focus. One convenient ray. Next thing is that, next ray we can take is that any ray passing through the center of curvature and incident on any point in the concave mirror or convex mirror, it bounces back in the same direction. Means it retraces their path. Because here, as we know that from the geometry of the figure, that any line drawn from the center to the circumference is always perpendicular to the tangents. Here is also the case same. Here angle of incidence is 0, so the angle of reflection is also 0. Now the two rays, if any ray we can draw from here and passing through the focal focus, after the reflection it becomes parallel to the principal axis. These 3 convenient rays, if a ray parallel to the principal axis incident on a spherical mirror, after reflection it goes through the focus. The reverse case is also true. If any ray passing through the focus incidenting on a spherical surface, definitely it should be parallel to the principal axis. And we can draw another. Here is the three ray we have drawn, but now I am going to draw another convenient ray. If a ray incidenting on the pole of the mirror, it obeying the law of reflection, and after reflection it makes the same angle with the principal axis as the incident ray makes. These are the 4 rays. By using these 4 rays, we can draw the ray diagram if you are keeping the objects at different places. Now we can, sometimes it was asked, you are keeping your objects at infinity, what should be the nature of the image formed by the concave mirror? If you are keeping your objects between the infinity and C, the second case, if you are keeping your object at C, if you are keeping your object at C and F, if you are keeping your object at F, if you are keeping your object or F and pole, what is the nature of the image? Just we should have to draw one by one, and then you can say that how the nature of the image should be. In the case of concave mirror, if we are keeping an object at the infinity, what should be? My dear students, as I have told you, how image can be formed by the spherical mirrors, like the concave mirror or convex mirror. Cases are different. If you have the object at infinity, if you have object between infinity and C, if you have object at C, if you have object at C and F, if you have object at F, if you have object between F and pole. Here the case is about, sir, we are going one by one. First of all, if object is at infinity, here is the case. It is a pole, definitely. Mn is the aperture. It is F, focus. It is a C. It is your radius of curvature. it is the focal length, means object is at infinity. A ray coming from infinity is always parallel to the principal axis. A ray coming from infinity is always parallel to the principal axis, and we are knowing that ray after reflection, the ray which is parallel to the principal axis passes through the focus, if object is at infinity, where here we are watching that image is formed at the focus, and it is highly diminished, inverted but real. Next case is that case 2. If here is the figure, if Mn again it is a concave mirror, case is the same. If we are keeping our object at between infinity and C, I have told you earlier that a ray coming from A incident on point Q, after reflection it passes through the focus and going in this direction. And next convenient rays we have taken here is that a ray coming from the A passing through the center of curvature C and incidenting on the point R, it bounces back, it repeats the same path and going to the passing through the C, means incident ray and reflected ray both passing through the center of curvature, and here image is formed. So what you are observing, the size of the image is smaller than the objects, nature of the image is real, but it is also the inverted. Second case. Third case is that if you have keeping the objects at the center of curvature, here is the C, just make the figure here your image is, your object is AB. Next, from A ray coming from A incidenting on the P, and after reflection it passes through the focus F. And next we are going to take another ray that incident on the pole. Here I am giving the P dash because pole is the P, and we are knowing that after reflection it is the same size, B dash, A dash, means if an object is at C, center of curvature, if any object is center of curvature, image will be formed at the same place of the same size, but it is inverted, means it is the nature of the image is it is inverted, it is real, but it is of the same size. Third case is that if you have again the pole P, here is the focus F, it is a C. If we are keeping our object between C and F, incident ray again passing through the C, passing through the F, because after reflection a ray that is parallel to the principal axis always passes through the focus F. After reflection it is going in this direction. Now we know that if a ray passing through the focus after reflection it should be parallel to the principal axis. Image is formed here. Where is the image? It is our A dash AB. It is again it is A dash and B dash. Here we are observing that it is bigger than the objects. When we are keeping the objects between C and F, image will form between infinity and C, and nature of the image is real, inverted, and larger than the objects. Now, it is the fourth case. Now, the fifth case, if you are keeping the object at the focus, if you are keeping the object at the focus, this C, we can draw a ray diagram like that. It is the ray incidenting on a surface, on a spherical surface at the point R, and it is in such a way that it passes through the center of curvature. Again, it will retrace the same path. So what you are observing here, that image is formed at the infinity, and that is much bigger than the objects. If you are keeping the object at the focus, image is real, inverted, but bigger in size. Now all 5 figures, 1, 2, 3, 4, 5, in all cases image is real, inverted, and either of the smaller in size of the objects, same size of the objects, bigger than the size of the object. It depends on the place where we are keeping it. Now, a case that is different from these 5 is that if we are keeping the objects between pole and focus, if you are keeping the object between the pole and focus, here is objects, a ray that is parallel to the principal axis passing through the C. Again, first of all, we should have to make the figure. Here is the Mn is the aperture, P is the pole, C is the center of curvature, F is the focus, AB is the objects. Here, what is it? That is, case is different here, because if just we can draw what you are watching here, a ray coming from A and incident on point P, obeying the law of reflection, and it is after reflection going this reflected ray in the direction of PQ. What you are watching here, if we draw the ray up to the infinity, they will never meet, and we know that if rays are not cutting each other, not intersecting each other, they don't make the image. How image is formed here? If you watch the figure from here, then we can see that a real, not real, but a unreal, a virtual. If you retrace back, a virtual image is formed behind the mirror, but here is the case is that image is erect and bigger in size, and it is virtual image. And I told you earlier that if you have a virtual image, we can't draw it on a screen. The example is that if you have a plane mirror, if you are standing in front of the mirror, if you just imagine that we are 4 meters away from the mirror, then you can watch that your image is formed behind the mirror by 4 meter. But when we go behind the wall where the mirror is fixed, then we cannot make that figure on a screen. So that is the virtual image. Here case is also same. It is a virtual image. The difference between real and virtual image is that we can draw, we can take the figure, we can take an image of the real image on a screen, but we cannot even able to take the virtual image on a screen. This is the major difference between real and virtual image. In the all cases 1, 2, 3, 4, 5, 6, all 5 cases, images are real, inverted, but here is the case.